Okay, so let's start. So today's discussion, we're going to see Introduction to NoSQL, and we will see a little bit demonstration on Elasticsearch, how we can use AWS to deploy Elasticsearch within seconds, and basic interface of Elasticsearch. So before we begin, just a quick question. Has anybody used any kind of NoSQL database or any kind of database? Only relational. Yeah, it's okay. So what are NoSQL databases? NoSQL databases are purpose-built for specific data models. If someone has worked already on SQL databases, you know the term SQL is very generically used for structured query language, but the query engine, how it works, is basically a relational database where you can have a relational algebra you can apply. You can do joins, you can have two tables, and often the SQL or a relational database, RDBMS, they are often used for very highly structured and ordered data. But what happened was in past maybe 5 to 10 years, the demand for unstructured data grew exponentially. So a lot of use cases which didn't need quite a few features of SQL database like ACID compliancy, query concurrency, locks, those kind of feature was no longer needed in many of the data sets. For that reason, NoSQL became more and more popular and got widespread adaptability. So NoSQL database, pretty much it can do anything what you think in a SQL, but of course there is a trade-off. So there are many varieties of NoSQL databases. Some are data models like document base, graph, key value, in-memory, and search. And Elasticsearch is a search database. So we'll only talk a little bit about that. So how NoSQL DB works? Simple thing, if you know from relational world that before you do anything, you always do data normalization. What is data normalization? Because you want to conserve space in NoSQL world. NoSQL world, SQL world. In SQL, because of when SQL came around, I will say 40 years ago, 30 to 40 years ago. And that time, the memory constraint was really high. You have to write a very efficient query engine, which is very low on RAM and very low on disk as well. So in order to optimize that, normalization has considered a de facto routine before you do any kind of data modeling in a SQL database. So if someone is not aware of normalization is simple as that. If you have an employee, say something like a book, ISBN, or these kind of author name, author ID. So what do? You create different tables using each of every element so that you can create a relation between them to create some kind of entity. So for example, you will do a author table or something like that, then ISBN, book title. So multiple tables, and to define a one entity of a book, say if someone is searching for I want this book for this author. So basically what it does, at the same time, it does multiple search on the databases and try to find the relationship and give you the data. So the benefit of doing that is you use less amount of data because you are not repetitively using anything. But in case of NoSQL, there is no such thing. You do not do any kind of normalization. You take the data as is and put it there. It is also considered, many world is called schema on read, schema on write. Although the concept is coming from data warehousing versus data lake, but similar thing here can be applied. We will see how in Elasticsearch, basically, when you ingest the data, you do not need to define a schema at all. Most cases, it will be able to do some self-detection of the data type and will give a generic schema, which works most of the cases. But of course, some cases it will not work. But in a regular relational databases, you have to create a table with particular data types define the storage, and even the size of your element. And then when you insert, and insert also has to be ordered insert. And that is how the data goes inside. Why they do it? They do all of these operations to maximize the performance of when you're ingesting the data. So the design model is completely different, but again, there is no good and bad solution. It is all about the use case. Last but not the least, there is no relationship. So each and every record or index or entity, they are self-sufficient and have all information. Then now you'll ask, hey, it's going to take a lot of space. Of course, it's going to take a lot of space. And because we are in an era where we are talking about gigabytes, petabytes, space is no longer a problem. Because once your one database fills up, you just add another node and that is done. So you don't worry about space anymore, neither RAM. And most of these NoSQL databases, they are very RAM hungry. So why we should use it? So first thing is flexibility. It gives you flexibility in terms of data model and schema. What data model you use, what schema you use. So in that way, it is very flexible. So if you want to write an application, assume you don't have a data modeler. So in these type of databases, you don't even need to find a data modeling tool or anything like that. Most cases, you will be able to just take the data from web in a JSON format and just ingest it. If you have a CSV file format, just convert it into it. Majority of the cases, you can do a simple data tagging. But even then, when you convert into a JSON, JSON doesn't have a data type. So most cases, it does on an auto direction, unless you're using some kind of special serialization like Avro or Parquet. That is a very special use case. Scalability, because of its nature of this NoSQL database is distributed computing. So you do not need to, for Oracle or MySQL, if you want to increase the performance of the database, what you do is basically you beef up the machine. You add more RAM, more CPU, and that is how the query engine is optimized. It will perform better because it is mostly like centralized approach. Because of course it has to store data in a defined way and query it. So query engine and the storage is pretty much coupled with each other. So that is how if you want to have scalability, it's very simple. You just keep adding nodes and you get scalability. High performance, because NoSQL database does a lot of compromise. We will talk about it in the next slide. We'll see the comparison. That is how it achieves a lot of performance impact when you want to ingest a data or something like that. And highly functional. Of course, flexibility is there. You can have UDF, user-defined function, these kind of things. So this gives you a lot of function, very similar to your SQL databases. So there are like types of databases, types of NoSQL databases. One is key value pair. You have document-based database, graph, in-memory, and search. These are like broad category you can define these NoSQL databases. Examples. So key value pair, one of the classic examples is your Redis or Amazon DynamoDB, and Azure also have similar tools. Pretty much every cloud provider nowadays, they have their own database distribution. Document is the MongoDB is the go-to DB whenever you're talking about document database. Document database, the concept coming from, if you're talking about a book, say information about a book, it has ISBN, it has author name, title, price, whatever. You take all the information and put in a one document and save it. You get another book item, you save another item. So each and every entity is a self-contained data. And that allows you very fast query also, because you are not doing any relationship matching. You just say exact match and boom, you get the data. And NoSQL is another term why they use, because you do not use a structured query language. Many cases you have pretty much JSON-based dictionary style query. A lot of people coming from SQL background, they find it hard at the beginning, but over a period of time, the concept remains the same for any kind of data filtering. Graph database, Neo4j, in-memory Redis, Memcached, and search is Elasticsearch. Elasticsearch is a database built on Lucene Index. Again, it is an Apache project, and they created it, and that is how it is used. A quick example of SQL versus NoSQL. So when we talk about workload, Workload is RDBMS. We are talking about structured data, relational data. When you want to have a relation like employee, those data, banking transaction, these are relational data inherently. If someone say, if you can use for NoSQL, yes, of course you can use it. You can use for anything, but the use case is perfectly suited and matured for RDBMS, those kind of very structured data where you have a limited size or limited, even each column is limited. Take an example, if you are an employee, when you join the employee company, your name is whatever it is, right? Your name, suddenly it will not become something really large string or something like that. Similar way, when you are talking about a salary, your salary is going to be like, if you join as a $5,000 a month, it's not going to become $1 million a month as an employee. Forget it. So certain things are a lot of things which cannot grow, or even as an employee database. You're not going to hire like millions of employees overnight. No, you grow the employee databases, these kind of slowly and progressively. So in these kind of scenario, your RDBMS is still a very good solution. Data model, again, we talked about normalization, strict schema, and schema on write. You have to be very strict about schema, because if the data type, what you are inserting into database, what is defined in the schema, if it doesn't match, it will break. It doesn't work. If anybody has used MySQL, Oracle, PGSQL, you know what I'm talking about. In NoSQL, there is no such thing. Schemas are pretty much flexible. You can change schema on the fly as well. But of course, when you do the query, you will pay the price of that. Like you may not get the right data. ACID compliance. So ACID is something called, ACID compliance is a very popular term in NoSQL databases, in SQL databases. That when you do a query on any NoSQL data, on a SQL database, it gives you certain kind of guarantee, like what features it's going to provide you. So these are some of these things. This is how it actually compromises the performance. So when I'm talking about ACID, the full form of ACID stands for atomicity. So when you write a query into Oracle, Oracle guarantees the operation will be done atomically. It means it will try not to do any context switching within the database engine. Consistency. What does it mean that? When you write a data in Oracle, and the moment your write API is successful, and right same time, if you do a read, you will get the exact data what you just wrote. So that is like consistency. So operation is atomic. When it's going to write, probably it will do a mutex log, write it, come back, API return success. When you read it, you get the exact, because they are probably reading the data from either the same location or the same source. I for isolation. It means you can have a transaction-based database. Transaction. If anybody has used SQL, you know you can create a begin transaction, do certain things, because when you do the transaction, it does in a temporary memory, or maybe swap space, whatever the space it is available. And once you commit the transaction, actually at that time it puts the data into the disk, and after that it is visible to any other process. So assume you are doing employee database, something, you are changing the name of employee, and that time you do in a transaction block. So when you change the employee name and you are still in transaction block, if someone is reading from the other side, they will not see the new name. They will continue to see the old name, because you haven't committed it. Once you commit it, it will see. Durability, of course, exception failure. These are all a lot of fault handling features are inbuilt in most RDBMS. So this is called ACID compliant database. In NoSQL, there is no such thing. When your API writes the data, okay, data has been written, but when it doesn't necessarily mean it has replicated across all the shards and clusters and replicas. So what does it mean? If I'm writing an employee name, say my name is Chandan Kumar, I wrote it, and it's a really large database, and someone is reading from the other side of the data node and reading, so probably they may or may not get this value, because when the API returns, there is no guarantee that it has been replicated across every node. Of course, you can modify the API parameter to do return only when everything is written, but you will pay the price in terms of performance, and that is what we are coming to NoSQL for performance. So usually people do not enable such feature. So of course, if you see a lot of these small things are there, which gives you a little bit. So NoSQL databases, they do a little bit of compromise some of the features of SQL in order to give you the performance or whatever flexibility they are giving. Because there are no free lunches. If they want to do everything, they will become a SQL database. So of course, they have a differentiating factor. Performance is usually disk dependent in RDBMS. It means faster the hard drive is. Say if you have SSD drive, it will run very fast. And in NoSQL, it is probably the most important is the capacity of the node, which node it is running, how fast the CPU is, how fast it is. So overall feature tells you the performance. Scale up, you beef up the hardware, like increase RAM, CPU in RDBMS. In NoSQL, it is most likely a distributed database, so you add more nodes. How you access it, interface, it is a SQL standard, and here you can have a REST or an object base. So now we'll do a little bit of demo on Elasticsearch. And also before the demo, I'll just talk about what we have Elasticsearch. So here we talked about Elasticsearch. So Elasticsearch is basically a search database, which allows you a JSON interface in order to see anything. So I have prepared a quick demo to show you exactly how basically we do on Elasticsearch. So I'll be spinning up a Elasticsearch instance on EC2. So I'll be using EC2, and it's basically a Dockerized container. So this is where we have right now nothing running. I'll just run this. I'm using Ansible script to deploy it. So basically what it's doing, it is creating an instance on Amazon, and then it's basically deploying it, a Docker container, and which has Elasticsearch inbuilt in it. So once the deployment is done, we will get the IP address of it, and we'll quickly use a REST tool called Postman, and we'll see how we can interact with Elasticsearch. And for traditional database users, you will see it a lot of difference, because in regular SQL world, you have been doing like select star from here, exactly that kind of thing, you don't have it. And also because these databases are very new, you don't find a lot of mature tools for easy use unless you are using Tableau or Power BI, they have inbuilt features. So this is my database, and I got this is my IP. And by default, Elasticsearch runs on your port 9200. So where is my Postman? Let me open my Postman. So Postman is a REST API tool. So you can have a REST call using that. You can use using your web browser also, but web browser can only do GET unless you do some developer tool if you install. So Postman allows you to do a lot of things. So I got this thing. So what I can do is I can simply do this, and I know my port is 9200. And if I do a GET, let me check if my container is up. Container should be up here. Yeah. So Elastic is up. You can see this is how it tells basically what is up. So I'm running a 6.5. Compatibility is this. So this is how you know it says, you searched it. So if you want to search anything, probably you will not find anything. So how you create, like in Elasticsearch, or they call index, if you want to compare it with the table. So how do you create a table? Like in Oracle, you create table, create database, something like that. Similar tool you have, but again, you have to do a get post. You can see, say if I want to do a put. So if I do a put on, say my index, and illegal exception, let me copy this one. So I do a put using this is my index and this is my doc and this is the value. So if I do that, I give some of the body. So whenever you do create an index in Elasticsearch, like any table in databases, what you do, you create table, you give a schema, right? But as we said, schema is not necessarily very important. It's all important what you give. So here we are giving user is a kimchi, post date, and this. And based on that, Elasticsearch will automatically try to detect the type of the data and then you can use it. So this is what we are having, user, kimchi, and this is what we create. And so this is what you created. And if you want to say query, see, I can see my query. So this is a very basic example I showed how to create an index, put some data and query. And of course, if you want to build the application, you have to build like any other application. And the use case for database is pretty much like any other database. If you want to create any application, this is very good. You have a very rich source of libraries in Python, Java, you name it. So that was the demo for me for today. You guys have any question? Okay, if you have no question, thank you everyone for joining the session.